mode, median. There's so many statistical formulas out there, right? Someone is talking. Can you please mute your mic? Yes. Hello. Someone has unmuted. Can you mute it? Okay. No. Okay. So today we'll learn a little bit of stats and all, and yeah, we'll wrap the session up. Yeah, let me share the screen. Okay, is my screen visible?
Yes, sir.
Okay.
Yes, sir.
So before proceeding into stats, and last time, like we'll check. See, this is the exact functions or the methods or the classes we have defined, right? We have checked a parent class and we have checked the child class as well. Like in this way, now you can write multiple child classes also. It's up to us. Okay. Yeah. Someone. Yeah. Someone is talking actually. So. Okay. Fine. Okay. See, so you can write methods also in this, right? You can write and multiple methods in developer class also. You can call it. It's the same way as you call in the employee class and all. Okay. So till here, we have finished. Like we have used a class, we have created a class, we have created an instance of that particular class. We have created class variables, we have created class methods, right? We have created instance variables, we have created data members, and not only that, like we have created inheritance flow also, right? By creating a new class and transferring the characteristics to that particular class from the parent class. So till here, we have seen all the functionalities present in Python, like the classes and all, how classes does the work and all, right? Okay, from today on, we will enter into the math. I told you, like mathematics is very crucial because by using the math only, we do different manipulations in the data, or we clean. That's what we clean the data or do manipulations in the data and all, and we feed the machine. And while feeding the machine, also we use mathematics to perform calculations and get the accuracy rate and all, and perform the predictions as well. Okay, so that's why the mathematics are very important in learning data science. Right? So now what I will do is so like I'll share a PPT now, and with this PPT, in this PPT we'll learn about statistics today, a little bit about statistics today. Okay. Yeah. So statistics introduction part. Okay. Population. So whenever you start the statistics now, so it's very important to learn the basics of the statistics and all, because everywhere, in each and every problem, the basics are very important, the fundamentals are very important. So you not to you need to make sure to, yeah, I guess, who is that one? Like someone has unmuted. Hello. uh, yeah, someone has unmuted their mic. Please mute it, because we are recording the sessions. Okay, fine. Yeah. So population. So coming to population. So in the statistics, we have so many terms like. So while dealing with Python, you have so many terminology like data types, classes, functions, methods, parameters, and like variables, constants. Likewise, no, each and every anything. If you take anything, any subject, no, you'll have the terminology related to it. So we need to understand those terms actually. Okay. So coming to statistics, the first term which you learn is population. Okay, population. So what do you mean by a population? So the first point, collection of all items of interest of our study. So you're collecting all the items. So that means, suppose, uh, consider this. So if you want to cook a bowl of rice, then definitely you'll collect all the rice grains, so which will fulfill our needs, right? So that's the entire population, right? Suppose if we want to do some water test, how quality the water is. So you suppose you have a bottle of water, you'll take the entire bottle. That means you're considering the entire thing. That is called as population. Okay, and it is denoted with capital N. Okay, remember. So it is denoted with capital N. Okay, numbers we obtain from population are called as parameters. So the numbers whatever we are obtaining from the population, the numbers in the sense like it might be the sum, it might be the minus of the entire population, or it might be a mean or something. So the numbers that we are getting from the population are called as it's not the mean exactly, it's just the numbers like the sum or something, whatever you are doing the manipulations there, whatever we are, if we are applying it to the entire population, the operations and all, those are called as parameters. Okay, example. So I have given here examples as well. Example of a college. In order to do a survey about job prospects, we need to go to the college. Sorry. Yeah, we need to go to the college and ask each and every student. For example, in your engineering college only. So your friends have placed, you and your friends have got placed in on MNCs and all, no? So some job interviewer, interview has come up to the college and they have asked about the placements and all. So what they need to do? So in order to have a clear understanding, they go to each and every student. They go to each and every student and they ask, so how many of them are placed in which company they are placed and all, right? Like what are the questions they have asked in the interview? Kind of, I'm just telling you what are the questions they have asked in the interview and how tough was the interview. So these are all the insights the interviewer is gathering from the college students, so that that might be useful somewhere. So example of a population is, so in order to do a survey about job prospect, the interviewer what he will do is he'll go to that college and ask each and every student about how the interview went and how tough was the question. And there's so many questions out there. So he'll ask those questions and he will come into some conclusion. Okay, so suppose if he is considering the entire college, that means few people might not be present at the time, right? So they might be absent, like a few people are at home, or some people might go to vacation and all. So it's very difficult for the interviewer to go and interview them, right? He can't go to the home or he can't go to the vacation place where the students are, right? So it's very difficult for him. So in stats and all, the population is very hard to define. I mean, anyway, by using mathematical calculations or something, no? So it's very hard to define and it's very hard to come to conclusion. I mean, you can come to conclusion if the population is very less. What if there are millions of data points out there in the project? Then what you're going to do? So it's very hard now to go to each and every data point and understand what if there is a pattern present in the data or not. It becomes very difficult for us. So populations are hard to define and hard to observe in real-time scenarios. That means the population, if it contains more than millions, sometimes it takes very much so much of time, right? It takes so much of time to understand about the population and all. So it's a time consumption process, and it's very hard to perform each and every operation on a single data point, or like then on the entire population and all, right? Yeah. So it's very difficult for us. So then what we will do? So then what we are going to do? So then we are going to take the samples out of the population. Okay. So what do you mean by a sample? A sample is a subset of population. Consider if there are 100 points present in a population, I'll take 20 points out of it. The 20 points is called as a sample for that particular population. That means the sample is representing that entire population, right? So denoted with small n. So population is denoted with capital N in statistics, and then the sample is denoted with small n in statistics. Okay, numbers we obtain from population are called as statistics. That's what. So the numbers, whatever the numbers you have, like numbers we obtain from sample. We do this as sample, sample are called as statistics. Actually, not population. That's fine. Okay, 1 minute. I'll just shut down the door and I'll come back. Yeah, sorry. Okay. Yeah. So it's denoted with small. And so what do you mean by this sample? Okay. It's very easy. It's easy. I'll tell you the example now. So previously for the population, we have taken an example of job prospects or job prospects conducted by some interviewer, and he wants to know how the MNC companies, how many companies are there, and everything, right? So he needs to go to each and every student. Okay. It's very difficult, I told you. So sample is something
Excuse me,
that,
sir.
yeah, yeah.
Your voice is too low, sir.
Okay, is it clear now?
Yes, yes, sir.
Okay. Yeah. Sample is something where okay, sample is something, sample is something. Suppose the interviewer, what he does is he goes to the canteen, because the canteen is the place where almost like students come up in between the classes as well, right? So there he goes there, and he randomly picks 50 of the students from the group, or randomly he picks the 50. That 50 is representing the entire college, right? Because the 50 people have got some information, like this is the company on some day has come up, and these many people they have recruited, and these are the guys who are selected, and also the 50 people will, whatever the information they have, na, they he gathers, the interviewer gathers there. So that means it's very easy for him. Instead of collecting the information from each and every student, he goes to the canteen directly. He randomly picks some 50 students, and he asks the questions, and he collects the information, and he comes to the conclusion. So that's where we are already predicting the outcomes. See, sample is something. So you are collecting the information from 50 of the people, and you are predicting that these many people have participated in the campus drive, and these many people got selected. So see, so that's where the prediction has started. So yeah, so that means you don't know the actual value, but you are going to predict the outcomes by using the samples. Remember, because the population is very hard to identify, and population is very hard to perform complex, I mean, some mathematical calculations or something, right? Are you getting my point? So we consider samples, we take samples in picture, and the sample is the representative, is represented the is represents the, sorry, sample represents the entire population. And the sample, whatever you're collecting the information, na, so you need to collect the sample in such a way where it gives you the maximum information. Remember. Okay. Yeah, good. So it's a subset of population. It is denoted with small n. Numbers you obtain from population are called as statistics. I mean, it's a sample actually. So interview 50 of them, picked at random. That's the point. Okay, sample analyzing. So when you do sample analysis and all, na, these are the advantages of sample analyzing. Less time. So the time taken for conducting the interviews in that example, compared to collecting the interviews of all the students, no, it takes less time, and it is easy to contact. Seriously, if you go to the canteen, automatically all the students will be, I mean, maximum of the students will be there, and you can collect the information, and it's less costly, right? It's less costly. So costly in the sense, like, it might be a financial matter, like financially it's less costly, because think of it. Suppose you have a sample of data points of millions, like 10 million you have. So if you are performing operations on the 10 million, obviously the resources are going to get wasted, right? So that means the resources are, if the resources are getting wasted, automatically the cost will increase, right? If you take a sample, like out of 10 million, you're taking only like 10,000 to 20,000, for example. Okay. That means, the resources on 10,000, 20,000 are very less compared to the entire population. So that's where you can reduce the cost automatically. Okay. So that's how, people does the, I mean, why people go for sample analysis and all is, these are the main reasons. Okay. So examples. So response about food in a cafeteria, right? So if you want to know the response, so the owner of the cafeteria, like, wants to know the response of how the food is. So how the food is. So what he will do, like, he won't go to each and every customer and he ask for the response, right? Like, in a day how many people are coming, randomly he picks some customers, and he gives a form, like, how gives a form like, how is the food. So you rate it from 1 to 5. So he collects the information like that. Like, suppose if 100 of the customers have come to his restaurant, so 100 copies he has got. In a day, on a day, like, 1,000 people are there. Out of 1,000, he has taken like 100 people, and 100 people customers have given 5 rating. That means the food tastes very well, tastes good, right? So that means that 100 people are representing the entire population again. So if the 100 people are liking the food, that means obviously almost all the people will like the food, right? So that's how you need to learn math and all, learn it in a practical way, so that you'll understand it perfectly. Okay. Hotness of a dish in a restaurant. Hotness, like, the owner wants to know the hotness of a dish. Like, there are almost like 50 dishes out there. So randomly he checks like five dishes out of the 50 dishes. Okay. Out of the if the five, he feels like if all of the five are hot, then he gives the rating. All the dishes are hot. So he can't check all the 50, right? It takes time. So what he will do is he'll randomly pick the samples and he'll randomly check the hotness of a dish. Okay, I've given two examples here. Your homework for today is like get two more examples. So understand what is population and what is sample. So in real time scenarios, no, I want like two more examples, at least two. Okay, that's your homework for today. Is that clear? Yeah, is it clear, guys? Okay, okay. So
Yeah.
now we have learned about status. I mean, we have learned about population and samples. Now we'll see how the data is classified. Okay, classification need to be known to perform data tests. You need to understand what the data is, what kind of data it is, right? To perform data tests and all. Now we need to know the classification of the data, particular data. So there are two types of uh, what do we call data here? There are two types of data available, and 1 minute. Yeah. So there are two types of data available. One is based on type. The other is based on level of measurement. Okay. So the entire data, again, I'm telling you, the entire data is divided into two types. One is based on type. The other one is based on level of measurement. So first we'll start with based on type. Let's start with based on type. Okay, let me check. Okay. So let us start with based on type. Okay. So first we'll check. Yeah. So based on type and based on level of measurements. First we'll start with based on type. Okay. I'll go to the whiteboard. Yeah. Types based on type, right? So I'm just types of data. That is based on type only. I'm just doing that. Okay. No, this is not coming up. Okay, I'll just draw with a pen. So there are two types, two types. The first type is categorical. The second type is categorical, and the second type is numerical. Okay. So types of data is divided into two types. I mean, there are two types of data. There is one is categorical and the other is numerical. So what do you mean by this categorical? So categorical data represents groups, the groups or categories. I mean, simply categories. It represents the categories or groups. For example, I'll tell you a few examples. Like the first example is car brands like Audi, BMW, Lamborghini, Mercedes, right? So there are different categories of cars available in the market. So according to the design and all, the cost and everything increases, right? So that is called as categorical data. Okay. And one more categorical data is answers to yes or no questions or truth or false. True or false. So we do true or false and yes or no, right? So yes is a category, no is a category. Same thing. True is a category and false is also another category, right? So those are called as categorical data. Okay. We'll just write examples. Car brands. Audi, BMW, and so on. Okay. Okay. Examples of categorical data. And we have numerical data as well. So what do you mean by this numerical data? So numerical data represents numbers actually. So if you get any numbers related data, that means the data entire data belongs to numerical category. Remember, numerical. So numerical is again divided into two types. Okay, one is discrete, and the other one is continuous. Continuous. Right? I'm going to place it here, and I'm going to place this here, and same thing. I'll use the pen. Numerical is divided into discrete as well as continuous. Good. Yeah. So discrete. What do you mean by this discrete data? Okay. So discrete data can be usually counted in a finite matter. That means you can count it. Like you can count it. Like you can count it in a finite matter. While continuous is infinite and impossible to count. Clear? Yeah. So again, I'm repeating. Discrete data can be counted in a finite matter, while continuous data is infinite and impossible to count. Continuous data, it goes on, goes on, goes on. It's continuous. And discrete is you can count it. Okay. For example, so discrete is something where you
Once
write.
explain categorical, sir.
Sorry. What? Hello. Hello.
Car brands, once explains at that examples not understand.
Okay,
Category.
car brands, like you have different cars available, right? Okay, forget about cars. You have different pens available, right? So while writing your exam, you decide which pen you need to buy, right? You have Reynolds, you have Cello, you have Pinpoint. I mean, there's so many categories out there of pens, right? So that means pens are divided into so many categories. You can choose whatever pen you like. So in the same way, cars, there are different cars available. Like you have Hyundai cars, you have Audi cars, you have BMW cars, you have Mercedes Benz cars, Benz, and you have Lamborghini cars available, in the market. So categorical data is something, and again, yes or no questions, true or false questions, like you are able to define them right separately. So those are called as categories. Yeah, and the numerical data is, it is discrete and it is divided into two types. That is discrete and continuous. And discrete is something where you can count it, and continuous is something where you can't count it because it is infinite. It goes on in the loop. Okay, so discrete, for example, discrete data is like your exam marks. So how much you will write, that is the maximum mark, right? Like you can count it from 0 to 100. You have these many marks that you can count it, right? So continuous data is the weight or height, it goes on, like from 0 kgs to, it goes on, it goes into tons, it goes on, it goes into suppose from zeros, from kilos, it goes into quintas, and it goes into tons and all, right? So it is continuous. In the same way, height, so from the millimeters, centimeters, feet, I mean, it goes on like that. So it is continuous. Okay. Yeah. So why I'm telling you these categories and numerical data is, so once you get the data set in data science and all, now you need to clearly understand what sort of data it is. So based upon the data only, you can use those kind of algorithms, use suitable algorithms actually. Okay. For that, you need to understand what are the types of data and all. Okay. So we are done with types of data. As you can see here, based on type we are done, and based on level of measurement now. Okay. Let us check level of measurement. I'm just writing it here. Of levels of levels of measurement. So while giving the measurements also, you have this uh, division of the data. Okay. So in this levels of measurement, it's divided into two categories. One is qualitative. The other one is quantitative. Quantitative. Clear? Yeah. So one is qualitative, the other is quantitative. I'm taking these out.
రెండు క్వాలిటేటివ్ ఒకటి క్వాంటిటేటివ్.
Yeah, guys, please mute yourself now because we are recording the session, so it's not good now. So mute yourself up. So whenever you have doubts, you can ask me. Apart from that, mute it. Okay. Again, qualitative is divided into two types. One is nominal, and then the other one is, ordinal. Here, yeah, and in the quantitative again, quantity is also divided into two types. One is interval. The other one is ratio. Okay. Yeah. So levels of measurement is divided into two types, that is qualitative and quantitative. Okay, and the qualitative is again divided into two types, that is nominal and ordinal. And quantitative is divided into two types, that is interval and ratio. Okay, so the nominal levels, what do you mean by nominal? Nominal, it represents categories that cannot be put in any order. Okay, nominal is something where you will not have a proper order. For example, the seasons, the summer. In India, it's from the January, it starts with summer and it goes into rainy season and it goes into winter, right? So in India, the seasons are ordered in this way. But if you change the geographical location, that's like, think like if you're in America, then there the seasons vary, right? The seasons vary there. So that means, they are not in a proper order actually. So that's why those are called as nominal data points. Okay, ordinal is something where it represents categories that can be ordered. Yeah, so there is an order for it. For example, yeah, what can I tell? Yeah, for example, if you want to rate a meal in a restaurant, right? So they'll ask people like rate the meal. So from 1 to 5 only, everywhere you will see that 1 to 5 only. That means 1 is the disgusting, the 5 is the perfect one. So take any rating. If it is from 1 to 10 also, 1 is the least and 10 is the highest rating. So that means you can keep everything in a order. So those kind of data is called as ordinal data. Okay, again I'm repeating it. So levels of measurement is divided into two types. One is qualitative and the other one is quantitative. In the qualitative, it is divided into nominal and ordinal. And nominal data is something where you can't you don't have any order for the data. And ordinal is something that can be ordered. Nominal cannot be ordered, ordinal can be ordered. So nominal example is the seasons. As I told you, like if you change the geographical location, the seasons vary, right? Those are not in the same order. And ordinal, like take example, the rating, anything, like if you're rating a meal or if you're rating a shirt or if you're rating any phone or anything. So everything starts from 1 and the highest point, whatever it is called as the best part. And the least one is the 1, suppose least is the 1. Right. So, and coming to quantitative, so there are two quantitative levels, that is interval and ratio. Okay, intervals and ratio, both represent numbers. However, ratios have a true zero while intervals don't. That means ratio can have a true zero value, but intervals, they don't have a true zero value, because interval is something where you start from 1 point and you end at 1 point. Right? Yeah. So for example, so interval example is, you can go for the thermometer. So thermometer, you have Celsius and all, right? So the Celsius, from this Celsius to till that Celsius, the thermometer is built. Or any if you want to like understand the intervals and all, take anything. Okay, and not only that, you have Fahrenheit as well, like Celsius and Fahrenheit, the measurements, it's all about measurements, right? And coming to ratios, we have done the math when we were in the childhood, like finding the length of the rope, if it contains like 2 parts and third part, and what is the ratio of it. So it's two-third of the length, those are called as the ratios here, right? So we'll discuss more about ratios, but not now. Yeah, we'll discuss more about ratios. Okay, and okay, so the main part. So coming to Excel, last time I told you, while importing pandas, while importing the CSV file by using pandas into Python environment. Before that, now we have shown you like to generate a line chat by using Excel, right? You remember? Yeah, by using line chat in the Excel, you are able to represent the data. So likewise, now you need to understand more about graphs here. You need to understand more about graphs and all. Okay, so graphs and tables that represent categorical data, that's the topic. Because of graphs and tables that represent the categorical data. So categorical data, can be represented into graphs as well as into tables. So what are those? Okay, so not all the chats we are going to discuss, but the basic chats. Okay, So the first table, the table part. So the table in which table you can represent the categorical variables is frequency distribution tables. Remember that, frequency distribution tables. Okay, after and frequency not after the frequency distribution tables. I mean, the you know how to generate the values in the frequency distribution tables, and you're done. So after that, so there are bar charts, pie charts, line charts available, line charts, and scatter plots. That means the point graphs. So there's so many graphs available, where you can represent the values from the table in the form of graphs. Okay, can anyone answer me? Why do you think already we have data in the table, right? Why you are representing that in a graph? Can anyone tell me?
Easy to understand, sir.
Perfect. It's very easy to understand, right? So if there are only 3 points, that's fine in the table. If suppose think like they are like more than 200 to 300 points, it's very hard for us, right? So it's very easy to understand if you represent that in a graphical way, right? So that's why people use graphs to represent something, and they can understand. If the visualization is good, they'll understand it very perfectly. Isn't that right?
Yes, sir.
Yeah, it's right. Okay. And not only that, people combine the graphs as well. Like people combine bar chart with the line chart. Are you getting it? Like people combine multiple graphs. So now if you're combining multiple graphs, so okay, so first let us think, like if you're drawing a graph, if you're drawing a bar graph or line graph, now you'll have two axes, right? X-axis and Y-axis, right? X-axis and Y-axis. So we already learned that. So you plot the points in between that X-axis and Y-axis. That's how you get a graph, line graph or bar graph, something. So now if you want to join multiple graphs, then you'll be having an extra axis. So you still till X and Y you have seen it, right? So you'll be having an extra axis. So if you're joining multiple graphs into one graph, like if you want to join bar graphs and line graphs, bar graphs and line graphs, at the time you definitely will have one more axis. Okay, so not only bar, pi, and these all, we have histograms as well to represent frequency distribution table. Remember that. And we have side by side bar charts as well. Side by side, in the sense, for example, at a particular point, uh, A, B, C, you're buying something. A is buying something, B is buying something, and C is buying something. Okay, at what cost is bought at that particular point, and what is the price they have given to the shopkeeper. So that's you can represent it by side bar charts as well. And you have scatter plots. You have scatter plots also available. That is the point graphs. By using scatter plots, also people derive patterns from the data, and people will decide whether the patterns are present in the data or not by checking the scatter plot. Clear? Yeah.
Yes, sir.
Okay. Yeah. I guess that's it for today. So we can wrap the session. So your homework for today is understand how many levels of data are present in the data. I mean, sorry, how many levels of data is present in the world, and yeah, try to understand about that. And not only that, give me two more examples for population sample as well. Is that clear?
Yes, sir.
Good. Yeah.